you think that that pod is going to be enough to serve your application. Let's say like on days like Black Friday, you would increase your replica count to 10 times as much. So you'd have 10 replicas. So that's one concept. And another concept is called horizontal pod autoscaler. So let me send you some links here that I think will be useful. So you can have some reading that I think will be interesting. So I'm going to paste this in. Well, let me paste it in
Slack, probably it's better.
Slack, yeah, so it's long-lived. So this is the replica concept, and then I also want you to know about this concept. So the second one is the horizontal pod autoscaler. And that's kind of a fancy name to say, basically, you can set some parameters for Kubernetes where your scaling will be done automatically for you. So for example, you tell Kubernetes, when my CPU load reaches 80%, I want you to scale up, and then you say what's the minimum number of nodes and the maximum number of nodes. Then the scaling will happen automatically within those ranges. But yes, what you were talking about just now is something that we're doing manually by setting CI variables. And when you set those variables and you say, I want my replica count to be 10, and then you will see 10. And I can probably show you an example of this in action so you can tie it all together. So here, in this project, if I go into CI/CD and I go into my variables, I have set my production replicas to 20. So what that means is that the production environment will when it deploys, it will automatically deploy to 20 replica sets. And if I go to operations and environments, all my environments should display here. So here you see the production environment, and you see that I have 20 replicas in production. So these are all the pods that are currently running in production. And
these might belong to one cluster. So that's why you said
they'll belong to a single cluster. That's right.
Okay, so it depends how many you add Kubernetes with only one cluster at a time, I guess.
You can add multiple clusters. So let's say if I want to use a dedicated cluster per environment, I can have one for tests, one for staging, and one for production. Right now, we're not telling you which cluster is relevant here, but we have an issue that will show you that. I think that Dylan is currently working on that. So it'll show you like what cluster we're talking about. And also when you have deployments, when you have pipelines that make a deployment, it'll show you what deployment, what cluster the deployment was made to. So yeah, there's all improvements that are coming up.
Right. So do we have issues also when you're not using the cluster for testing, for example? So everything is in production. There is nothing going on in development at the moment. Do we allow you to auto turn off like a cluster, or will you still have them up and running even though your environment is not useful?
So if there are no deployments to your cluster is still up and running, and we have no control over like the decommission of your cluster. That's kind of the thing we were talking about earlier, is that we can interact with your cluster and its current configuration because we have the credentials for that cluster, but we don't have the credentials for your cloud provider. So to kill the cluster would mean you would have to go into your cloud provider and kill it. So yeah, we don't have access to do that currently.
Okay, so there is a user persona who does this kind of management of clusters, like.
That's right. Yeah. So there will be an operator that deals with all the infrastructure and stands up the clusters and kills them and adds capacity and things like that. Yeah.
Right. Can I ask a question which might seem harsh for the ops people, but so our job is to kind of change the, not very harsh, I'll not put it harshly, change the job scope of the ops person into more high-level tasks rather than these nitty-gritty configurations they were doing before auto DevOps. So are they going to be unemployed after GitLab is fully adopted and successful?
Not really. So I think that all the customization and the provisioning may or may not happen inside of GitLab. So there are a number of advanced use cases, and this even happens internally, where that the GitLab integration does not handle. And I think that as the Kubernetes project evolves, I think that it's unrealistic for us to say we're going to cover every single use case of how you can provision a cluster. Especially because it not only has to do with Kubernetes, it has to do with the cloud provider as well. So no, I don't think that that's going to be the case. And there's another kind of MO that people are using when they deal with clusters. So we have one very large retail customer that uses ephemeral clusters. And what that means is that they create a cluster just in time as part of their CI pipeline. They deploy stuff to it, they test it, they allow users to interact with it. And then when the pipeline finishes, it kills the cluster. So this is all part of that sort of workflow will always need to have an operator in the middle to say, like, what's the capacity, what are the limits, what is the access for this cluster. So no, I don't think that we're going to eliminate the job of the operator anytime soon. No.
Okay, cool. Thank you.
So I know that we talked about auto DevOps, we talked about the Kubernetes integration, we talked about ChatOps, and we talked about cluster cost optimization. Is that right?
Mm-hmm.
We already talked about all those things. So I feel that one thing that we didn't get to talk about last time was serverless. Is that right? Do you remember us talking about serverless or chaos engineering or run?
No. So definitely not chaos engineering, and serverless, I think no. So João touched a bit on it on my meeting with him, but.
So I think that the most relevant for us to talk about is going to be serverless, since that's a category that we have at a minimal maturity. So it's out there, it's available, users can interact with it. And then maybe if there's time, chaos engineering is planned. I guess runbooks is minimal, so we should talk about runbooks as well. Yeah, so let's talk about serverless. Let's see, let me see if I have a project here.
Maybe if we get some time at the end after these three topics, we could talk about immediate features like the one you tagged me on, if there is time. Otherwise, we can talk about them separately.
Well, so I guess, what do you think would be more useful for you to talk about? I don't want to just choose like all the topics that we that we cover.
I do want to have a background, so of the vision and a bit of explanation for each. So that's very useful for me. And before I start doing actual work, I'd rather have as much as I can, the complete understanding. Because in my understanding, the UI work is not that massive in our stage group, but more like the experience of how users do things and what they expect.
Yeah, I guess that's a fair characterization. I think that there's a lot of stuff that's coming up that may require the experience to be more crisp and clear. There may be a lot of UI changes that accompany that. But like specifically on the serverless space, I think that that's a useful thing to talk about. So yeah, maybe let's start there. Okay, so serverless. Let's talk about serverless. Where to start? I think that, are you familiar with what serverless is, kind of in principle?
Just what João explained to me. So when microservices are not running, kind of kill them to optimize resource usage.
Well, so I think it goes a bit further than that. I think that serverless, it's a misnomer, right? Because serverless kind of means that there's no servers, and that's not correct. So everything still runs on servers. I think that serverless at a high level means that there is little to no management of the infrastructure where you're running your workloads. And one great example of this is AWS Lambda. So for example, AWS Lambda is a serverless offering that allows you to, for example, upload a function or an application, whatever you want. And let's say that my function is, is just doing, it's an image reduction function. So you upload some image to a URL, and it returns you a smaller image. So here's like the couple of huge benefits that that offers. First of all, when you don't have to worry about infrastructure, you have more time to focus on the application that you're writing. And it could be whatever. It could be a function, a microservice, a monolith, it doesn't matter. So developers love that because application developers want to focus on writing great apps and not necessarily have to worry about, how much capacity do I need? What machine size should I stand up? What kind of resources do I have to create? So that sort of thing. So that's one huge benefit. And the other very big benefit is that it's elastic. So if you have no requests, you don't pay for anything, right? And as your traffic starts growing, there's nothing that you need to do. So let's say if today you only have 10 users, the service will scale up just enough to serve those 10 users. If tomorrow you have 10 million, the service will scale up to serve 10 million users, and you have to do nothing. The service does that for you automatically. So that's a huge benefit, the fact that it's elastic. And kind of the third one, one thing that I should add to be elastic is that it scales down all the way to zero, right? When you're not using it, you don't get charged for anything. And the third benefit, it's of course cost. So before, I used to stand up like a couple of virtual machines, one for my application, one for my database. Maybe I had a load balancer, and I was paying for those machines 100% of the time, whether I had traffic or not. If I had zero traffic, I paid 100% of my bill. If I had 80% traffic, I paid 100% of my bill. Right. So a huge thing there is cost. So that's kind of at a high level what serverless is, right? And then let's talk about GitLab serverless specifically. So GitLab serverless is based on Kubernetes. So Kubernetes has this project called Knative. Let me send you a link to Knative so you can kind of read what it's all about and what pieces it has and stuff like that. So Knative has two main components, but the main one that we concerns ourselves with is the serving component. It has another component that's called eventing, and that is basically, so let's go over those two concepts. So the eventing service is a specification that has a bunch of event sources that can determine when a service will process a workload, let's say. So it's just kind of based on events, what event sources can I use with my serverless service? That's the first component. And the second component is the serving component, and that's kind of the big one. So the serving component is great because it, so Kubernetes cannot like natively scale to zero. We have the concepts that we talked about, like the horizontal pod autoscaler, that you can set some parameters to scale up and down, and also the pods that you can create some replicas. But Knative has this native serving component that is much like I was talking earlier with serverless, is request driven. So without you having to configure much, the service will scale up and down to 0. So this is useful, let's say, when you're using it as a hosted service, you only pay per request. And different providers have this service. In Google's case, it's called Cloud Run. In IBM's case, it's called hosted Knative service, and so on and so forth.
Right. And is it the equivalent to the AWS Lambda you were talking about?
Well, so not really. So they both are considered serverless technologies, but the Knative one has, it's a middleware, if you can think about it that way. And it enables a couple of things. So what you pass to Knative is a container. What you pass to Lambda is anything. It's just code. Let's say it's a function. What you pass to Knative is a container, and that container could contain either a function or a full app, right? So kind of the concepts are different, but the high level idea is the same, that you're only allocating resources to workloads that demand it. If you have no workloads, then no resources are being allocated. Knative has, as I said, a couple of different concepts because it's using Kubernetes primitives or Kubernetes concepts. It also deals with all your networking. So Knative uses a service mesh, what's called a service mesh. And a service mesh is basically what's in charge of the interaction between all the components in your cluster. So networking, storage, security, things like that. The mesh is in charge of all of those things. So when you pass a container to Knative, Knative will create what's called a service. It's called Knative service. And the Knative service will do all of those things that I just mentioned. So Knative is different in a couple of different ways. So we call it serverless, but let's say if you want to add Knative to your Kubernetes cluster, your Kubernetes cluster is running all the time. So it's not scaling down to 0. So let's say if I'm a customer and I want to use GitLab serverless, I have to provision it either on a cluster that I'm creating in some cloud. That's kind of option number 1. Or I can use a hosted service. If I use a hosted service, then I am really not paying for anything when there's no traffic. So that's kind of a concept that, well, I guess is not super important, but it's important to keep in mind that serverless doesn't mean 0 costs a lot of the times. Because a lot of the times you need infrastructure. So for example, people who are running serverless on their own data center, it's serverless in principle, right? So their developers don't have to worry about infrastructure or anything like that, but they're paying a fixed cost. And a lot of people are doing that.
That's you mean a data center on premises. So they pay the cost of maintenance or whatever it is, the cost of maintaining the data center.
That's right. That's correct. Let me see if I have a cluster defined here from this project. I don't think so. All right. So there's a couple of reasons why we chose to start with Knative here at GitLab. And the first one is, because of our deep Kubernetes integration, right? We are making big bets on Kubernetes. We want to be the best tool. If you want to use Kubernetes, we want people to think of GitLab. Like GitLab is easy to use, so all the Kubernetes related things we want to happen on GitLab. So Knative was kind of a natural way for us to get started, because Knative is a set of things that you install on your Kubernetes cluster, and then you get kind of a framework to do serverless things. So that's really great. Right. So there's a couple of things that happen in GitLab that you don't get out of the box with Knative. So the first one is that you don't have to provide a container in order to deploy something out there. We are doing all the legwork of that for you. So let's say you can only concern yourself with writing some code that, let's say it's a function. And then GitLab CI will take that code and through a couple of pipelines, will build your Knative service as a container and we'll deploy it to Knative for you. So that's like kind of benefit number one. If you were to visit a hosted Knative service today, that service is going to tell you, hey, point me to the container that you want me to deploy. So that's benefit number one. Benefit number two is that once you deploy a service, you get all this telemetry that is coming back to you. So for example, you get the number of pods that are being used for your Knative service. So let's say if you have no traffic, you're going to see no pods. If you have a ton of traffic, you're going to see a bunch of pods. So that gives you a good grasp of how costly your service is being and how many resources you are consuming. So not costly in dollars and cents, but costly in the resources that you are consuming. Yeah.
So is that for you to improve it? Is that visibility useful for you to improve your services if it's very costly in terms of resources?
So that visibility, I think, is useful, let's say, when you're running your own Kubernetes cluster and you see that your service is so popular that is using like 99% of your CPU, you probably want to increase the size of your cluster. Right. So it's good for you to plan around the infrastructure that you're using. So that's number one. And then the other thing that we're doing for users is that we're showing them the number of invocations that are happening. Let's say we're specifically focusing on functions. So and let me show you what I'm talking about. So we are saying deploying functions, function details. So here, for example, you see that we are showing you. What did it do? Sorry. Function details. Let me open up this image in a different tab so we can zoom in on it a little bit. So here we're showing you, as I said, the number of pods that we're using. So I see that I have a test container and I have one pod that is currently being used. Here I have the invocation. So I see that I had 0 here and then it spiked to 12 and then it went back down. So that gives me a good snapshot of like the times that my service is more popular or the times that it's being used the most. So those are kind of the things that you can see when you drill down inside a service.
Right.
So right now, our serverless offering is labeled alpha, right? So there's a couple of things that we know we want before we can call it even beta or just GA, generally available. And some of those have to do with the fact that Knative is a new project. So Knative has been around for about a year and change, maybe a year and a half. That's number one. And number two, there's a number of things that you can do in Knative manually that we want to provide for you automatically. So for example, one of those things is, let me share my screen again. One of those things is the need to provide a domain. So when you install Knative onto your cluster, before you're able to install Knative, you need to provide a domain where your functions will be served out of. So you see here, well, this install button should be grayed out. It's not. So here I have to provide a domain. So here I would say knative.info.
Is that the DNS?
Yeah, exactly. That's the DNS. And then when I installed Knative, part of the installation of Knative will install that service mesh that I was mentioning earlier called Istio. And Istio installs an ingress controller. And an ingress controller you can think about is the path for your Kubernetes cluster to have traffic to the outside world, to and from the outside world, the internet, let's say. You know what? I just thought of a useful resource that may help. So the first time that I talk about the concept of an ingress with people, it doesn't immediately click on what it is. So let me show you this image, which I find very useful. So here you have a Kubernetes cluster in the back, and this gate is the ingress controller. So the ingress controller basically allows traffic to come in and come out. And then you can do like a bunch of advanced configurations that puts conditions on that traffic, like which traffic can come in, and which traffic can come out. But that's what an ingress is. And of course, when you have that gate, you get an IP address that is kind of the address for that gate that is allowing the traffic to flow through to your cluster.
Who does ingress belong to? Like who wrote this service?
So there are different companies or there are different flavors of ingress. One of them is from this company called Nginx, and that's the one that we use for when you install ingress onto your cluster. Like here, if I was to click install on this button, that would be Nginx.
Right.
However, when you and that's here. So like when you look for Nginx ingress,
it's
you can
open source, right? That's why we're using it.
Yes, but Istio is also open source, and they have another flavor of ingress, and that ingress is the one that we're using for serverless. So when you install Knative, as you can see down here, I clicked install, and I received an endpoint. So that is the address for my ingress.
And then ingress will redirect the traffic to the IP of the port.
Well, as long as you have set up your DNS endpoints correctly, then yes. So here, if I'm an operator, the next step that I would have to do is map that domain, and hopefully I own that domain. I'm not sure that that's the case, but I think I do. I would map that domain to that IP address. So I would have to have an entry. So yes, knative.info here. So here I would go to manage, I would go to DNS, and I would map custom resource record to that specific IP. So here I have another one, so I'm gonna say it's this one now and save. So all the traffic that comes to knative.info will now be routed to that IP address.
And maybe it's a silly question.
No such thing as a silly question. All questions are good questions.
Ingress's kind of main goal is to optimize the traffic and also do security, or just optimize the traffic, or neither?
It's even less than that. It's just allow traffic.
Right.
Without ingress, there's no gate, and there's no traffic in and out of your cluster.
And
so the main goal of ingress is to allow traffic. That's it.
Why is it a separate service and it's not integrated in the Kubernetes kind of functionality?
Well, so a lot of people don't want to allow external traffic into their cluster.
At all.
They never install ingress into their cluster. You know, their cluster may just be dealing with like internal workloads. So it's just receiving interactions through the Kubernetes API, and it never needs to talk to the outside world.
Okay, I had a click now. Banks, for example, keep some of their database closed completely, and some of their
absolutely. So there's a lot of clusters that are part of a bigger deal, and they don't need to have an ingress installed on them.
Okay.
And that last link that I sent you on Slack, I think is very helpful to for those high level concepts like pods, nodes, ingress. all of those things are described there, I think, in good detail. So check that out when you have a chance.
I feel like I'm in university again, which is great, learning new things, but I feel like, oh my God, I'm doing a degree again on Kubernetes this time.
Well, so yeah, I don't think that, don't feel like you have to become a Kubernetes expert.
No, but I want
to know enough to say how the, yeah, and it's great if you want to become an expert. That's awesome. But I think that it's good to start with what the main interactions that our users are doing with their clusters.
Yeah.
I think that starting there is a good starting point.
Yeah. And in time, I would learn more, obviously. So I should be patient.
Yeah. So the ingress basically allows that traffic in and out. So as I was saying, one of the things that we are requiring the user to do is that you have to enter a domain, right? Like you saw me do here. And then you have to map the ingress IP to that domain with your domain provider.
Manually, yeah.
Manually, yeah. So what we want to do is we want to provide you with a domain automatically, that you don't have to worry about mapping IPs to domains. We want to provide you one automatically. And then if you want to customize it, then sure, you can go ahead and provide your own domain and do the mapping. But we want to provide a domain automatically for you.
Where are domains hosted, if I may ask?
What is the what, sorry?
Are domains hosted somewhere?
Well, so you can use any domain provider. In my case, I'm using Google Domains. But just like I'm using Google Domains, I could be using any other provider that I want. I could purchase an address in GoDaddy and map that to my ingress IP, or any other domain provider. It doesn't matter.
Okay, so you would have to maybe import only where you have your domain, where you have purchased your domain, and then
you would have to go to like their management console and do what I just did in Google Domains. Yeah.
Okay, cool.
So that's one thing. The domain is one thing that we consider we need before we can call this out of alpha. And the second thing is security. So right now, let me see if something deployed here. Right now, when I deploy a Knative service, or let's say when I deploy a serverless function, it is served over HTTP. So it is not served over HTTPS by default. And if you want to serve it over HTTPS, you can do that, but it's a manual process, just like the domain. So here you see this last topic called enabling TLS for Knative services. So this is in order to serve your traffic over HTTPS. And these are all the things that you have to do in order to make that happen. So it's like a bunch of manual work that you have to do in order to make that happen. So of course, we like to do that automatically, so you don't have to go through all this stuff. And you know, in reality, Kubernetes operators probably feel comfortable doing this. But we want to make it easy for everyone. If you want to get started with serverless and you're an application developer who is not an expert in Kubernetes, we want to make it easy for you as well.
Gotcha.
So those are kind of the main things that we're talking about. And we have an epic that we're calling viable serverless. And so one of the things is, where did my epic go? Oh, well, I guess that this was all moved, huh?
Oh, so. Yeah,
here. So this is the epic where we're tracking all the things that we want to do before we can call serverless viable. So here's automatic domain, which I was just talking about. The other one is automatic SSL TLS, which I was just talking about. This one is about invocation insights and logs. So right now, if something fails in my Knative service and I want to like search for logs, we don't provide logs in GitLab. So, you know, you would have to go into your cluster and start digging to get those logs. And that's painful. Support more runtimes. So this is an interesting one. Serverless uses this concept of runtimes. So if I write my function, let's say in Node.js, then I need to have a runtime that will know how to build a container for my function. And we described this in the serverless docs. So GitLab serverless docs. So when you're building your function, you kind of specify what the runtime is. So this is the GitLab CI.YAML, and this is the serverless.yaml. So there are kind of two templates that you need to provide in your project. One is the GitLab CI.YAML, and the other one is the serverless.yaml. And here, you describe which runtime you want to use to build your function. So here it's using the Node.js runtime. And currently, we only have a couple of runtimes. We only have like Node.js, we have one for Ruby, and we have one that's for applications. But let's say if you wrote your function in Go, we don't have a runtime for Go today. So you would be out of luck. So before we can call serverless viable, we want to provide more runtimes than only two that we support now.
Right. So if somebody was using a language that we don't provide the runtime for, could they provide is it a config file that?
They would have to provide us a container, actually. They would have to have a container that tells us how to build it. Right. That would be the only way that you could do it with a language that's not supported by our runtimes today. So yeah, so we want to basically support more runtimes. And then once we have those four things, we'll call this out of alpha. So that's what we're on now.
Before we move on from all these features that we're discussing to be added to serverless, I guess the logs are somehow user experience and UI related, but automating the first two processes is more like backend work, correct? Or
yes, that is correct.
And do we kind of do discovery of what preferences or settings the user would want around these automations, if any? So do we go out and ask?
So, there's not a lot of choice for things like SSL. Like for SSL, you need a certificate installed in your cluster and you get HTTPS. So I guess that that one, we could probably have a good feeling to say, we know the path forward. Then when it comes to subdomain, the user really has no interaction with the subdomain. So they don't have to go outside of GitLab to manage it. So what we think is like, we'll provide you something that's like GitLab serverless.io, and then we append the name of your project or function at the beginning. That's what we give you. I don't think that we would get a lot of like actionable information from doing research for things like automatically providing you with a subdomain.
Right. Just the editing capability, I guess, as you said.
That's right. Yeah. So let me show you what this looks like today. So when I go to serverless, each one of my functions gets an HTTP endpoint. So you see here, the domain that I provided was this part, knative.info. Everything else is built with like things like the name of my function, my project ID, and my environment. So that wouldn't change. What would change is that the user doesn't have to provide us with a domain before they can install Knative. And buying a domain means you're spending money. And then using a custom domain means you have to go out of GitLab and configure and stuff like that. So I feel that there's not a ton of discovery that we have to do there. As long as we provide them a domain, they don't care what it is.
Yeah.
They just care that they have an endpoint where they can call their function.
So it's just a choice between I have my own domain and I want to input it, or I want GitLab to create a domain for me.
That's right. That's correct. Yeah, so that's it. So when I click on each one of these functions, as I was showing you earlier, I see the pods and the invocations, and that's about it. So I see, because I haven't used this function, It's not using any pods. So that's great.
We have 4 minutes, but maybe that's also a silly question, but I'm gonna ask it anyway. So we have this serverless kind of graph showing you the traffic when it goes up, when it goes down. What's the difference between this view and monitor, the monitor view in Auto DevOps? So the view of your containers, I guess.
Yeah, that's a good question. So the monitor view is not an Auto DevOps deal. The monitor view has to do with the Kubernetes integration.
Taking the data from Kubernetes and exposing them in the GitLab UI.
Exactly, yeah. So regardless of if you're using Auto DevOps or not, we'll show you that traffic there if you have it configured. So the difference is that if you have a function-based project, metrics. If you have a function-based project, this view that we use today is not showing you invocations. It's just showing you kind of high-level metrics that have to do around the state and the usage of your cluster, and also its traffic, like HTTP errors, latency, things like that. And there are other higher-level ones, like CPU and memory, that are being shown as well.
But that's for your whole deployment and not each function.
That's for my whole cluster, not for each individual deployment. Then you can filter it down by environment.
Right.
Yeah, so the high-level metrics that you can show here.
Would integrating a function in this kind of drop-down be useful to see like the usage of resources per function?
Well, so think about this. This cluster health, for example, is showing me what I was telling you just now, CPU usage and memory. If I have 10 functions deployed to my cluster, which one would you show here?
A combination, I guess the average maybe, I don't know. Does it work like all together or separately?
It's all separate, yeah. So each service is deployed independent of each other. And you may care about one, and I may care about another. So showing me all of them, I don't think that provides a lot of value. I do agree that if we are showing you monitoring specific deals in multiple places, right? Like this one shows me cluster health, which is great. I mean, it's useful. Then when I go to metrics, it shows me another set of metrics. Then when I go to serverless, then it shows me another set of metrics. And maybe that's okay. Dylan also thinks that, we should show you all metrics in a single place. But I think that different metrics, like context, matters. If I'm an operator, I care about CPU and memory. I don't care about how many times your function, the developer, has been called. I don't care. And then as a developer, I do care, how many times my serverless function has been used for a number of different reasons. Yeah. So that's what I think.
I see your point. Okay. I think that's a good place maybe to do research on the use cases, personas.
Absolutely, yeah. So the thing is that our serverless offering is so young and immature that we have to do those things before people will start taking it seriously and adopt it more. We do have a couple of users that are already making use of it, and that's great. And the things that we're doing to make it viable is based on their feedback. Like HTTPS and domain and all that stuff has to do with their feedback.
Cool. Well, I have to jump to the other meeting.
Same here.
Thank you so much for that. Very, very useful.
So there's a couple of things that we haven't talked about yet. Specifically, I think that it would be useful to talk about runbooks, because that's something that's out there today. So yeah, if you could put some time on my calendar, again, we'll talk about runbooks.
So next week, Thursday, I'm going to be in the Netherlands. So for me, I think Tuesday would be, I'm going to meet GitLabbers.
So Tuesday, I'll be at GitLab Commit in New York. So I won't, I think Monday, Tuesday, and Wednesday is out for me.
So maybe that it will have to be the week after the next. Or Friday. I'm going to be in the co-working day of the Netherlands. So I was thinking maybe it will be tricky. But I'm going to put something in for Friday with just one note. Might change it to the following week.
Okay, sounds good.
See you later at the meeting.
All right. Bye, Maria.
Bye. Thanks.